Good morning. Today I will be demonstrating experiment number 1, which is LED interfacing with microcontroller. Already I have explained this code in the class. Here I am going to demonstrate the practical session. So our first experiment is LED interfacing with microcontroller. Port selected is port 4, which is connected to LEDs. Delay is generated by using software. So software subroutine has been written. Crossbar has been enabled to enable the port pins. Port 4 is configured as an output port by writing FF to P4DM out. Since LEDs are common anode fashion, by writing 0 we can turn LEDs on. So since there are 8 LEDs, we have written hex value 00 on LED. So all 8 LEDs will turn on. It will remain on for 100 millisecond delay. So we need to call delay subroutine for value 100. To turn LEDs off, we have to write 11. So we have written hex value FF on LEDs by which LEDs will be turned off. The delay we have called is of 100 millisecond. So LED will be off for 100 millisecond. So with this, LEDs will turn on for 100 millisecond, LEDs will be turned off for 100 millisecond. And this will be continuous since it has been written in while one loop. So continuously LEDs will turn on and off, which we call as flashing of LEDs. Now once we complete the code, we build the code, we get the hex file and we download that hex file on the hardware. To download that hex file on the hardware, we use the downloader, that is bootloader. For bootloader, we need to connect our board to the PC. So our development board is connected to PC by this USB cable, and we have to make this board in program mode. For that you need to press this button which we called as ISP, in system programming. When you press this button, this LED will be red LED will turn on, indicating that the mode is program mode. After pressing this button, you need to press reset button. So when you press ISP and reset button in boot downloader, it will be enabled. So you need to open it, browse for your hex file, select the hex file, open it, and you need to download. So when you press download, this message will display successfully downloaded image. Say OK to it. Now come back to hardware board. Now previously board was in program mode. Now we want to run the code, so it should be in execute mode. To have the execute mode, we have to again press ISP button. So green LED will turn on and then press reset. Now board is in execute mode and right now it is running the code. To see the output, what do we expect as an output? We do expect that when LEDs are connected to port 4, LED should turn on and off. So the port is port 4, which has to be connected to LEDs on ASK board. For that you need to refer the manual, which includes this table, which will give you the detail about the pin connection. So port 4 of microcontroller board is available on PL6 connector and LEDs are available on PL8 connector of peripheral board. So when we want to connect port 4 with LEDs, we need to connect PL6 with PL8. So I will be connecting PL6 from microcontroller to PL8 of peripheral board. So LEDs are here. You could able to see LEDs are on for 100 millisecond and it's off for 100 millisecond. So it's difficult to read the status of LED. I will increase the delay and we will see the effect of maximum delay on the LED flashing. So I will modify my code. Previously it was 100 millisecond. Now I am going to make it, let's say, 500 millisecond. So it will turn on for 500 millisecond and turn off for 500. So make the changes in your code, and again you need to rebuild your code. Once you build it, you will get the updated hex file. So make sure you are selecting updated hex file, and that updated hex file you need to download on the board. So again we will make board into program mode, and we will open it. We will browse for the updated hex file. I will select the updated hex file. I will open that hex file and I will say download. So again we have updated the file. Now we will see the effect of modified delay. Previously it was 100 millisecond. Now we have made it 500 millisecond. So again I am going to connect port 4 to LEDs, that is PL8. I am going to connect and see the change in the output. So all of you please observe it carefully. Now all the LEDs are flashing. For this flashing, delay considered is approximately 500 millisecond. I think now you could able to read the status of LEDs. LEDs are turned on and off. So this is the output of flashing of LEDs for first experiment. You can make the changes in the display pattern. If you want, you can turn alternate LEDs on or alternate LEDs off. That pattern could be there. Or half of the LEDs are on, half of the LEDs are off. That also possible. So I will again show you. I will make the changes accordingly and you can see the output. If I make the alternate LEDs glow, you can see what are the changes. I'm just making the change in my code and I'm going to dump that file, and I think I could able to you could able to observe the changes at the output. Allow me to download. Just I am selecting the file, that is updated file for alternate LEDs, and I am going to download that file. It will take a minute. Okay, so this kind of patterns could be there. So the basic pattern we do expect, it should be flashing of LEDs, turning LEDs on and off. Thank you.